All right, we are going to look at plates and boundaries today. So, the lithosphere is divided into 7 major tectonic plates. Remember, the lithosphere is the top mechanical layer of the Earth that consists of the crust and the top layer of the mantle. It's the solid portion, right? So there are 7 major solid portions of the Earth. These are the major tectonic plates named after the continents or oceans, major oceans that they're on. You just need to know those 7 major, and the only additional one that you need to know is the Nazca Plate right here next to South America. When we're looking at the plates, we will either be looking at a map that is prime meridian centered. This is the map that you're probably used to looking at because you learned about the prime meridian and equator in world cultures. But we can also spin the globe and look at the other side of the world with the Pacific Ocean being the center. And that's often something that we look at with plate tectonics because the Pacific Plate is a very large plate, and it's really important. There's lots of activity at that plate boundary. When plates come together, they're called plate boundaries, and there's 3 types of plate boundaries: divergent, convergent, and transform. Divergent boundaries are where plates are moving apart. Convergent boundaries are where plates are coming together. And transform boundaries are where plates are not coming apart or moving together. They're actually just sliding past each other. So when we talk about the plates and the types of boundaries, we use the rhyme transform, slide, divergent, divide, convergent, collide. That helps because it all rhymes, but also divergent and divide start with a D, and convergent and collide start with the same letter C. So this is just another image that looks at the types of boundaries and the types of formations that occur because of those boundaries, but we're going to look at those more specifically on this next slide. So there's 3 major types of convergent boundaries, them coming together. There's oceanic to oceanic convergent. So if the crust is oceanic on both sides, you have something called subduction, where one ocean plate moves under the next. That same thing happens when oceanic plates collide with continental plates. So when we have continental crust, then again, that more dense oceanic crust moves underneath it. When a plate moves underneath another plate, it's called subduction. So it's pulled underneath and kind of becomes, that bottom part of the plate melts and becomes part of the mantle again. If we have 2 less dense continental plates colliding, then instead of one going underneath, fully underneath the other, they usually both just kind of fold up on top of each other. And that's where you have really, really large mountain ranges. It's important for you to understand that every single time some crust is pushed up, or some of the lithosphere is pushed up, and so is magma, when subduction occurs. So you usually have mountains of some kind. It's just the kind of mountains that are forming are kind of based on the type of crust that is colliding. So we're going to look at crust colliding when oceanic crust is concerned first. So we have oceanic crust. The more dense oceanic crust is always going to sink underneath the less dense crust. If there's continental crust involved, that's always going to be the least dense. So when we have this subduction, there's going to be mountains that are forming on the least dense plate. If it is continental crust, then they're going to be really high mountains because continental crust is always already higher than the oceanic crust, right? That always also, or typically also, pushes some magma from the mantle up. So you usually have volcanic mountains. So if it's a continental oceanic collision, then you're going to have high mountains on that continent with occasional volcanoes. When it's 2 oceanic crusts, one is still going to be slightly more dense than the other, so that one's going to be the one that subducts. It's going to be a little less of a collision, but there is still going to be mountain formation and magma rising, so that's where you get these volcanic islands, those volcanic arcs. every single time you have subduction, so an oceanic plate sinking underneath another plate, you have what's called an ocean trench, which is a very deep valley where that one ocean plate is moving underneath another plate. So that trench is pretty important. The very last type of convergent boundary is when there's no oceanic plate involved. It's two continental plates. They're already high, they come together, they get higher, so you get really, really big, tall mountains, that folded mountains that occur because of continental to continental collision. Some real life examples are the Mariana Trench, that is an oceanic to oceanic conversion. Oceanic to continental conversion is where the Andes Mountains are along the western edge of South America. Those are volcanic mountains, so there are volcanoes that are still active in the Andes. And then, of course, there's an ocean trench just west of South America as well. And then the tallest mountains in the world, the Himalayas, that are still growing taller every day, are formed because of continental convergent boundaries. So two continents, India and Asia, are colliding, and they're still moving together. So every year, the Himalaya mountains get a little bit taller. It is important for you to understand that volcanic islands don't just occur at plate boundaries. They can also occur at weak spots in any oceanic plate. So that's what Hawaii is. It's just a weak spot in the Pacific plate where magma from the mantle is rising and creating a hot spot. As plates move, new islands, new volcanoes are formed in that one spot there. Divergent boundaries are where plates come apart. They divide, divergent divides. So if it's two oceanic plates, there's something called an ocean ridge. So we've got the magma coming up underneath the ocean and creating a new ocean floor, ocean basin. If it happens on a dry continent, then what happens first is the continent starts to rip apart. So you have something called a rift valley. Eventually that rift valley will fill with water, right? So it becomes kind of a new ocean basin. So the Mid-Atlantic Ridge is a really prime example of a diverging oceanic plate boundary. So the Atlantic Ocean is actually getting wider every year, a little bit wider. And then the East African Rift Valley, so right here there's a big, huge break in the continent of Africa, and that plate boundary actually extends up this direction to the Arabian Plate, and that's what the Red Sea is. It's like this new sea from the plates dividing, and that valley eventually filling, getting low enough and filling with water from the Indian Ocean. Transform boundaries are our last type of boundary. Transform boundaries are where plates are moving in a particular direction but not toward or apart from each other, so they're sliding past each other. As you can imagine, they're big giant slabs of rock, and rock are not smooth, so they get kind of caught up on each other, and as they're moving, a lot of tension builds, and when that there's enough tension and enough movement in each direction, then there's a big slip, and that big slip and breakage of the rock, when that occurs, is an earthquake. And so where you see these really large earthquakes are usually at boundaries, and the most active transform boundary is the San Andreas Fault. And we'll look at that in just a minute in California. And there it is. So the San Andreas Fault is a very large fault line. So part of California is literally kind of shearing off of the rest of California, and that's why there are so many large earthquakes in California. So those are our boundaries. I hope this helps.